Good morning, everyone. I hope you're all doing well. Before we start, I just want to apologize. I had a shower a little bit too late last night, and then my hair is a bit poofy. Sorry if it's distracting at all. Today, we are going to cover the new platform that I have made. This is much better than the last one. I think if you squint your eyes a little bit, it looks near identical to the old design, but I think there are some upgrades here that are very useful and very necessary for Jugglebot's continuation. So let's get right into it. If I do this, ha ha ha. Also, I've turned on the settings gone now, but I lowered the latency, so hopefully we are more in real time now. But according to the little preview thing, it looks like we're still a good 15-20 seconds out. What can you do? Eventually, I'll figure out how to do this in actual real time. Yes, so the overview of this problem is that for a Stewart platform to work properly, the whole thing really, you want it to be as rigid as possible. If the platform is moving around and it's also flexing at the same time, then it's going to cause issues with getting the platform to be in the correct position at the correct time, especially when it's moving around quickly. That flexing would really muck things up. No good at all. So it has to be real stiff. And the old platform was literally impossible to tension properly, because when you tensioned one string, let me get rid of myself, when you tensioned one string, it would make the other strings go loose. And so you would tension one up and then the other one goes loose, and then you tension that loose one up and then the first one that you tensioned will go loose. And it's just like a never-ending tension game until all of those kind of like diagonal carbon fiber tubes were all quite flexed in, which is good in some regards, but is not really ideal in many regards. So really, I wanted these strings to be working together rather than against each other to tension the entire thing super tight. The platform must also support the hand, because the hand is what is actually doing the throwing and catching. And if I show you quickly what that actually is here, my terminology I've been a little bit kind of loose with, I think. I'm trying to stick with this whole thing is the platform, and this bit in here is the hand. So this guy that goes up and down is the hand. That's what's actually like catching and throwing the ball. And that has to be supported by the platform, because that's actually what's going to be doing the throwing and catching. And I also don't want to buy new carbon fiber tubes, because carbon fiber tubes they're not super cheap, and I need to wait for them to arrive, and that's just a pain. It's so much, clogs up the process quite a lot. So I wanted to reuse the carbon fiber tubes that I used in the old platform, as well as some other ones that I've got lying around. I also can't cut these tubes. I can't cut anything really right now precisely. I only have hand tools available to me, and I have tried many times to cut different tubes and rods and this sort of thing, and I can never get them like to the millimeter correct. Every time that I've bought them, and I've bought them to a specific size, they have been much more accurate than what I can do. So I prefer to just buy them to the correct size rather than having to cut them down myself. Hopefully one day I'll have proper tools and I can do that myself, but for now I just need to buy them. So I think the first major struggle with this was the geometry of the whole problem, because I wanted to revisit some old ideas that I had before, one of them being having an inset hand. And what I mean by that is that for this platform as it is right now, the hand part sticks up quite a lot. So these balls are what actually connects to the legs of the Stewart platform, and the whole platform extends up quite a bit above that. And I think it would look cooler if the whole thing was just kind of like below this point. So I wanted to have the hand, this guy in here, be entirely below these balls, which looks a little something like this when it's not all fully put together. Oh, so let me put that back on. So I wanted to have the hand be fully inside, and I considered this idea like a year and a half ago, but I realized that there were too many collisions with the legs, and I again realized that this time. I was very keen on this, and I still feel like it can work, but the geometry has to be very deliberate. The whole thing has to be structured a bit differently, I think, for this to work. Part of me feels like it's possible, but not a problem right now, I think. And I also had, so as I mentioned before, I have the constraint of I need to use the same carbon fiber tubes that I used before. And this actually made for some very interesting problems, and I want to actually show you. Yes, sorry, thank you for letting me know. I'll just fix that up real quick. Okay, cool. You should be able to hear me and see the CAD now. Thank you, Darkman. So I made. I'll just start it again. So my old CAD model of the old platform was workable, but I didn't really design it with, I don't know, too much forethought, to be honest. But now that I knew what I was going for, I started off completely from scratch and started off with this template sketch, or template like model, where I could start by setting the lengths that I cannot change. For example, this 370 is one of the lengths of the tubes that I bought and don't want to cut and want to reuse. So that is fixed. The diameter of the platform is not fixed, which is why it's white. That can change as I change other lengths. These angles and dimensions in here were kind of arbitrary, but by setting these sketches, and like this 277 and the 340, these were all the carbon fiber tubes that I had to reuse. And by making these sketches and then kind of like building this template, I could then build the rest of the assembly around that. So you can see this template is the very first part in my assembly, and I just built everything around that template. And in theory, I don't want to try it now because I don't want to crash my computer, but in theory, I should be able to change any of those dimensions and the whole thing should adjust accordingly. Sometimes the fillets and stuff kind of mess up a bit, but that's the idea. And that helped a lot. That would have been a lot more difficult to do if I had not built those kind of fundamental sketches first. And yes, another constraint with the geometry here is that the string that pulls the hand up, so if I make me big, this is quite awkward to hold. This string, let's get that in focus if we can, whatever. This one that actually pulls the hand up will ideally be completely parallel to the path of the hand the whole way up. I was struggling to figure out a way to represent this in a way that makes sense, so hopefully this animation makes sense. But if we have a look at these three different animations, the string is attached to the block can only move purely vertically. The string then goes up and over a pulley, or in this case just like to the pulley and straight down, because this is a lot easier to animate. And that string is pulling down at the exact same rate in all of these simulations. But you can see that when the string is completely collinear with the path of the block will go up at a steady constant pace at the same speed as the string the whole way up. But the more offset that pulley is, the faster and faster the block will go as it reaches the top. This kind of makes sense geometrically, but it's a little bit tricky to visualize in my mind. So hopefully these animations make sense. And in my mind, this can be kind of a useful thing. Like I can kind of use this to my advantage if I want to get an extra little sort of like an extra little kick when the ball gets thrown. I would say not conservation of momentum, but more conservation of length. Conservation of the length of the string. This is all assuming it doesn't stretch, but I think that's a pretty fine assumption for my case. yeah, I think that I can use this so that towards the last little movement of the hand, it gives the last little push and throws the ball up super high. Because really, to throw a ball, you don't need force. Force doesn't matter. What matters is speed. If you can just get it going fast enough, then it will go higher, and that's presumably a good thing in my case. However, the reason why I don't want to do this is because the inverse kinematics of figuring out where the platform needs to be to put the hand in the right spot, because the hand is really what matters here. The platform is only kind of like a peripheral thing. What I really care about is the hand matching the position of the ball and catching and throwing the ball. So I need to position the hand very, very accurately. And the inverse kinematics of that, which I will cover at some point, is already tricky enough. And I don't want to add this extra business to it for now, at least. I think I want to get the easy case of the strings being straight done first and just verify that that actually works. And then maybe if we want to get a little bit of a, then I can introduce this afterwards. We'll see how we go. Cool. So how to make the whole platform as snug as a bug? Because the problem is that printed parts will flex and they will bend, and especially over like not half a meter, but like 40 centimeters or so, all of these parts have a little bit of flex. So I want to tension it so that all the parts, so the whole thing is real kind of tight, which is, thank you, brought to you by Didine. I'm enjoying presenting it all. Yeah, and I only need to tension this whole thing once. If I just get it tight one time, then I'll never need to undo it and it will just stay tight. And to give you a bit of a spoiler, that's how tight I got it. It's pretty good. And ideally, I will have one tensioning mechanism for the entire platform so that I can just tension one thing, and rather than having to kind of like go around, like, you know how when you're tightening like the lug nuts on like a car wheel, you got to like do that star thing. I don't want to have to do that because I want everything to be perfectly homogeneous. I want it all to be the same tightness the whole way around. And I don't think I'm going to be able to do that if I have to tension 3 different things or 6 different things. So I want to show you my CAD mechanism in CAD because I think that will make the most sense. I need to make a CAD thing where you can see me in the corner as well. So the tensioning mechanism that I've got is this one string here, and this is one whole long string the whole way around. And let's start at the start. So at the very beginning, the string goes in through this little hole. I haven't done this in the CAD because I'm lazy, but there's a little kind of like slot through here. If you can kind of see that the string goes through. Ignore this part of the string. That's not actually there in real life. So the string goes through here, and then a bolt goes in this hole. And that bolt just secures the end of the string. So you can see, oops, in real life, that looks like this. If we can get it to focus. So there's just a little knot going around that bolt, and that way that can never come undone. There's like a figure 8 on a bite around the bolt. That's never coming undone. And then that string, its next path, it goes down around this little pulley, and pulleys are important here because if I just have the string go around the bolts, then there'll be too much friction and the whole thing won't tension equally. So I've put these pulleys in so that I can get everything nice and equally tight. It then goes up and around here, up around this next pulley, and then down around the same idea, up around the next pulley, and then down. And then to actually tension it, I've got probably my favorite little mechanism that I've come up with in a while. This little ratchet guy here. So the string goes around and it goes through this hole to just secure it onto that spool. And then as I spin this, it will ratchet on and it will never ever go back like this. There is literally no space for this to turn back the other way. It just does not go. And so this slot here is the same size as a screwdriver that I've got, a flathead screwdriver. And so I can just tension this up, and it makes a very satisfying like click, click, click sound, which I'll put in the actual video that I make for this when I eventually do that. And yeah, that just ratchets up and it's never coming undone. to try to alleviate some of the tension, because I don't really want these parts, these kind of, I don't know what you call them, fronds, I guess, to alleviate the strain on them so that they're not just constantly being stressed. I have a bolt that goes through the back that I initially is just like the axle for that, for this ratchet to spin around. But once I've done it all, once I've gotten to the tension that I want, I just tighten that like way up. So this is sort of clamped to this lower part. I don't think that that clamp would be enough to hold it back from spinning by itself, but it would hopefully help. I don't know. But that works super well. I am very, very happy with how that ratchet mechanism worked. I think maybe it's worth showing you the design that kind of led to this, which was this one, which if you watched one of my earlier videos, I kind of briefly showed this thing off. This was my, I don't know, one of the ideas for a platform to make. And I had the same sort of thing where the string goes around the pulleys, all around the outside. It's not really focusing very well, but I had that same ratchet mechanism. And it's worked very well. For one of them, actually I think I still have it. No, it's changed a bit. For one of them, the teeth on the ratchet got really mangled up, but it still worked. And for all of the other ones, I just changed one of the dimensions I changed like the thickness from 1 millimeter to 1.4 millimeters, and that made all the difference. And now all of these teeth, all the fronds on the ratchet are solid, even when I've tightened them up very, very, very tight. All right, let's get back to this. Okay. Cool. So the next part was, how do I tension the 3 strings going to the hand? So these, let me go back to big. This hand in here is pulled up by 3 strings, and those 3 strings need to all be exactly the same, because if they're not, then the platform will tilt like this. And if the platform is tilted, then the whole thing is going to throw a ball on a very weird angle. And I don't want that to happen. I want the platform to be perfectly flat. So I need those strings to be exactly the same length. And if you've been following this project for a little while, you might remember my old tensioning mechanism that had little screws, and I still don't know what to call them. I spent like a good 2 minutes yesterday, or whenever I was making this, trying to come up with a name for this piece. I think I ended up calling it a slider, but they had this little slider that went along a bolt, and that was what I used to tension the strings. And I did the same sort of thing here. Knots will not work. I tried that a long time ago. I cannot tie knots in the exact same place. I have the open offer for you to try. It's very tricky to do. So yeah, I made a similar sort of mechanisms to what I made before, where as I screw and unscrew the long bolt, the slider will move along it. Well, let me get rid of me. And yeah, so the string, like the end of the string is tied around that slider, and that as the slider moves up and down, it will move the string and tension or loosen it accordingly. Also, I'm going to look at the comments at the end so it's not too distracting for me, because there's a bit of latency, and I think it's going to be more clear if I do that all at the end. Thank you though. I'm very interested to see what they say. You'll also notice at the very end of that bolt, if I can draw... Nope. Oh, well, whatever. At the very end of that bolt, there is a nut, and that nut is Loctited on, and that just basically stops the bolt from moving itself. So it can just spin, but it can't actually move. And inside that slider is a threaded insert, so that way it actually slides along as the bolt gets loosened and tightened. And the effect of this is that it can control the position of the cup of the hand very, very precisely. So what I did is I set all the strings to be like loose, basically, and then raised the platform all the way up to the top, and then slowly tightened each one until that top part of the hand was just touching the bottom part, like the ceiling part where that pulley is. And that way they were all close enough for now. I can make small adjustments later if I want to. But yeah, that worked very well. And you'll also notice that if I get rid of this, the path of the strings is completely straight. So if we look here, just as a, I don't know, refresher to see where we are, this moves up and down as the strings pull it. And we wanted that string to be as straight as possible. And you'll see, if you look from above, that's the hole going into the hand. And this is the hole going down to direct the string elsewhere. And that is completely lined up. They are perfectly straight the whole way up. So whatever rate the string is being pulled at, the hand will always move up at the same rate, irrespective of where it is along its path. Because otherwise, if it was all the way down here, with a bit of an offset, it would move up slowly. And then as it gets higher and higher, it will move up more quickly with the same amount of pull, which is not ideal. Let's put that up there. I really need a third monitor. All right. So another tricky thing that I have finally sort of fixed once and for all is how to attach the carbon fiber to the 3D printed parts. This is something that I've been doing for quite a while because all of my designs for the last little while have involved carbon fiber tubes. And I've gone through different iterations of trying different things. And to be honest, I've not been super happy with how any of them have worked so far, except for this one. But this one's a little bit kind of temporary. We'll see. I don't know. Just to give a bit of understanding of what's actually going on here, most of these carbon fiber tubes are in compression, but some of them are in tension. So I can't just rely on a compression force holding them together. And importantly, these forces will vary as the platform is moving around. If it just throws the ball straight up, then all forces will be fairly standard, like fairly easy to deal with. But if this is on a weird angle, it's going to be pulling this whole thing at some strange angle, and all the forces are going to be weird and very hard to predict and hard to deal with because they're hard to predict. So I wanted to make sure the carbon fiber tubes are very solidly in place and like robust against both tension and compression. They need to be solid. I considered having strings to pre-tension all of the tubes, and you'll notice that that's actually what this one was doing. So these strings around the outside, these were all here to pre-tension these tubes so that they're all in like mega compression. And I was considering doing that, but this whole mechanism is quite complicated and I didn't really like the complexity that added. It wasn't really nice. So instead, I just went with a simple solution to put a bolt through both ends of the tube. And yeah, that was very easy to do. It took a surprisingly long time to drill through the carbon fiber tubes. And if I were to do this again, I would have made a little jig and probably made some sort of like drill press sort of thing or just bought a drill press to drill all these holes in the same spot. You'll see when I post the proper video about this how I actually did that, but it was kind of slow, very tedious, just holding the hand drill. And it took a long time. Carbon fiber is strong. But yeah, this is super solid. For reference, I also undersized those holes a little bit. So those holes are 2.5 millimeters diameter, whereas the bolt is like 2.8 or 2.9 or something. So the bolt, there's like no wiggle room basically. And also the kind of tubes that the fittings, the 3D printed fittings that the tubes fit into are fairly tight as well. They're not like full interference fit, but they're fairly snug. And that is solid. There's no wiggle room at all. Those tubes are well in there. Another thing, let me get a drink first. Another thing that I have been battling with since a very old version of the platform is how to work with constant force springs. For reference, these are springs where the force is more or less constant throughout the whole travel of the spring. So they're little kind of spools of metal. and they lengthen and they exert more or less the same force along their entire like length, which is very unique for springs. Not many springs are like that. Well, normal springs are definitely not like that. And I've been having some troubles with them because I thought that they were really easy to work with, and I can just do what I was just doing with the rod, have the carbon fiber tube, have the constant force spring right on the tube and go like that. But it's very noisy and they kind of wobble around a little bit. And as they wobble, if they touch anything next to them, then they can get caught. And I had a couple times early on where if the platform moved really quickly, the hand would move down, and well, if the hand moved down very quickly, then the constant force springs, when they were getting wound up, would get caught, and because they got caught, they would not spool on themselves, and they would just kind of spool in the air and get all tangled up, and that was just such a mess. So yeah, that was not good. They need a lot of space so they don't get caught, especially when you're moving quickly. And I've noticed that a larger drum is quieter, so I think that that's just because it means that it revolves fewer times. So yeah, it's just less movement, less noise. And so what I've gone with now is just like it's basically just a large drum that's like bigger than the constant force spring is when it's in its smallest state. And that means that it's like, it really kind of grabs onto the drum, and you can extend it like pretty much the whole way out and it doesn't slip off. And that's working quite well so far. It's very quiet, actually. I'm really quite happy with it. Cool. So what is next for the platform? I've got a couple things. The first one is definitely to add a laser gate, which is something that I will probably do in one of these live streams soon. Maybe the next one. We'll see. To give a quick little TLDR of what the laser gate is, to give sort of like an extra sense of what is happening to the ball for Jugglebot, so the Jugglebot can kind of feel what's going on, I want to add a sensor in so that when the ball leaves the hand, we can get a very good idea of the speed and the direction of that ball. Because if we can get a good estimation of that, then that helps a lot with the prediction of where that ball is going to end up. If we know where it started and where it's going very precisely, projectile motion is a well and truly solved problem. Like that's easy. And predicting where it's going to end up will be much, much easier if we can know where it left off and how quickly and all that sort of stuff. So what I want to do is add a laser gate, which will basically just be a laser across the opening here, where on the other side of that laser is a photodiode, and when the laser is broken, we know that the ball is in the way, and when the laser is unbroken, we know that the ball has left. And because the balls, I've got these new balls that are very spherical. Thank you to Daniel Simu on Zulip for the suggestion for these balls. They're very spherical. So because they are spherical, we know the diameter of them, and if we know how long that laser was broken for, very precisely, which photodiodes are very good at, then we can have a very good estimation of how fast that ball is moving. I still need to do some work on this to get it kind of fine-tuned, but my preliminary testing so far is very, it bodes well, I think. I think this should work really nicely. The other side to that coin of estimating, of like measuring how fast the ball is going and what direction it's going in, is to add an IMU, which stands for Inertial Measurement Unit, which basically measures like tilt and roll, like pose sort of things. And so I'm going to add an IMU onto the platform on these little holes in here, if I can get them in frame. And that way I will be able to, as soon as the laser gate is triggered, I'll be able to read from the IMU what the pose is. Obviously, I'll have to account for the fact that that's in a wonky spot, but that shouldn't be too bad. And yeah, and then I'll have a very good estimation of both how fast the ball is going from the laser gate and also what direction it's headed in from the IMU. I should also potentially have a pretty good idea of the exact position in space based on how long all the legs are. But that's I don't need to add an extra sensor for that. And hopefully that's precise enough, but time will tell. Another thing, which is not super critical, and I haven't had any issues with it so far, but it's only been like 2 days, so we'll see, is to modify these pulleys here, if I can get them in shot, because right now, if any slack gets on here, then this string can come out, just then it went back in, but it can come out and go and end up beside the pulley, and it gets very jammed up in there. But as something that I noticed when I was putting together these bits, let's look at this. When I was putting together these bits, because these pulleys have a V in them and the string is smaller than that V, it fits entirely inside it, which means that this tolerance out here is like nothing. Like in the CAD model, especially if I zoom in lots, it's like, oh yeah, there's heaps of room there. But in real life, I'm not gonna be able to show that on the camera right now, I think. But in real life, that tolerance is so small. The pulley just doesn't touch the printed part and the string can't get out. So I'm thinking of making these pulleys covered in the same sort of way so that no matter how much slack gets in the system, the string just can't come out. I think that would be just nice to have, because I've had a lot of experience so far with strings and pulleys and strings coming off of pulleys and landing in the little side bit in here and getting all jammed up. And it's very annoying to deal with and can really kind of cause some proper problems if it happens at the wrong time, at least. So I want to cover these up to lock in the pulley, lock in the string. But it's not super critical, so we'll see when that gets done. I also want to increase the length that the hand strings adjust over. So, come on. It's so awkward. All right, these little adjusty things in here that I showed before with the sliders, I want to make that section a lot longer. And seeing this in real life, I realized that I have all of this space down here to extend this out. And I'll explain in a second why this is the shape that it is. But yeah, this like 15 to 20 millimeters or so that I've got is good, but having more would be nicer. It was surprisingly difficult actually to tension all that up and to get the strings all the same length. It took a bit of iterating to get them all the same. So I think having just a longer travel for adjustment would make that a lot easier. And yes, to explain why this is the shape that it is, it's kind of an oversight, but also kind of, I knew that it had to be awkward anyway, so I didn't really bother too much with it. If this will update. This has to sit over, this has to be right in the middle, ideally. If it's not right in the middle, it's going to cause problems, and well, like geometric problems, and it's going to be really annoying to deal with. So I want these strings, you can see how closely together I tried to put them all. They are as close to the center as they possibly can be. And so is also the CAN hub, the central hub from the live stream last week. That doesn't have to be in the middle, I guess, but it looks nicer if it is. And I didn't want to have to reprint that, and like that was working fine, so I just thought, stuff it, I'll just put this thing on top. And that's why it is that shape. It also has to mesh with the bolts that are in the base, so it's got all these wacky legs. And this part was surprisingly difficult to model. It took a little while, but it works now, and that's all that matters. Let's go back to here. Yes, another thing that I just thought of yesterday, actually, as I was thinking about this live stream, is to move the position of the ball joints. I think this is actually going to be easier back in CAD. To move the position of the ball joints to, rather than be flat on the bottom here, which is good, like there's a lot of movement that I can get out of this before it like hits any limits. Like that is fine. Nothing is hitting. That's a happy position. But I think I can make it even happier. I can give it an even greater range of motion if I put these balls, rather than being flat, if I put them on an angle on the outside of this, like on this convex face, and if I have them collinear with the legs when they're in their resting position, which I don't think I'm going to be able to drag this back into right now. It tends to be unhappy when I get towards the lower limits, or any limits of anything. But yes, if I make these balls, see how this is coming at like a weird angle, and this is at a fairly standard position. If I make that ball, for reference, that's got a little axle on it. If I make that ball collinear with the leg, then I think it will give it a greater range of motion. And I'm very intrigued by that because range of motion is good. I like range of motion. And that's it. Yeah, that's everything. Actually, there's one other thing that I want to cover, which I didn't really... This was probably the most oversight thing that I had in this whole process, was designing this piece, because this piece has to do a lot of stuff. It supports these vertical carbon fiber rods. It also has to support these tensioning strings and the IMU, but that's kind of secondary. And it also has to redirect the hand strings so that they go... Actually, I don't think I've animated them in. No. It has to redirect the hand strings so that they go from the top of the hand, up over this top pulley, down through here, and then down into the middle point, because we want all the strings to be middle to middle. But yeah, the oversight thing was this guy here. This sticky outy bit is only actually attached with like 2 or 3 millimeters of material, and that's not enough. That's nowhere near enough. The first one of these that I printed failed halfway, and I just wanted to give it a test. Actually, maybe I can just show you. Yeah, I've got it here. This guy, weak as, no good. And I recognized this in the CAD before I printed the first one, thankfully, because it's a long print. And my solution for this was not to redesign the whole thing, because that would have been, I don't know, arguably the right thing to do, but also quite tedious. So what I've done is I've added a bolt in here. So this bolt just bolts this extra little sticky outy bit onto the main thing, and that bolt goes like way deep. Like it's well in there. So, and that's solid. Like on that test one that failed, I tried adding the bolt and I could not flex this part at all. So I'm actually pretty happy with how that worked out. It was a very last minute solution to that problem, and it worked quite well. And actually there is one other thing that I want to mention that I meant to put in the slides, but I forgot, is that this tensioning mechanism, while it worked extremely well to tension, it hasn't actually worked super well to do what I wanted it to do, which is to hold everything in a fixed position so that it cannot move whatsoever. And the reason for that, put this over here, is because these strings are routed around pulleys and they go between all of the different sides of the platform, this middle part, I don't know if I'm going to be able to show this very well. Yeah, I can't really, you're going to have to take my word for this, but the middle part can still move a little bit. If I bend this side to side, it can still move because the string just moves around the pulleys. And that's not really a good thing. I don't think it's that bad of a thing because there's not going to be a huge amount of force going through this anyway, but I'd prefer if that wasn't the case. Like kind of the whole point of this tensioning string is to stop that from happening. So I'm not too sure how to fix that, to be honest. I still want to keep with one single tensioning mechanism, and I'm going to have a think about how I can route the string around so that the resulting central part, this guy in here, can't move at all. Because right now it can. Maybe that will actually work. Yeah. You can see it's got like a little bit of wobble in. Yeah. It was a little bit, like, the amount of wobble that you could see then was more than what it actually is because my other hand is moving around at the same time, but it can still move a little bit. So I need to fix that at some point. But as with all things with this project, I have gotten it to the point where it is workable for now, and so all of these other like next stops things, these are going to happen at some point once the actual base platform becomes a problem. And this is something that I actually have been noticing a lot with this project, is that whenever any part or system or whatever has a problem, initially I would try to fix that problem straight away and like remake the thing, whatever it was, and solve the problem. But I've actually noticed that it's often better to just leave it. If it's still workable, as long as it's not a fatal issue, then it's better to just leave the problem as it is and then start to tally up all the other problems that that thing has. And it's kind of interesting if you already have the mindset of I'm going to be changing this thing at some point anyway, you're a lot more, at least I am, a lot more open to seeing the other problems with it. It feels like I'm less connected to the things. Like it's going to be gone anyway, so let's fix all the things rather than just fixing the one. I don't know. I found that to be very helpful. So yeah, I'm going to collect up a nice big list of things that's wrong with this platform, because inevitably there will be, and then fix them all at once. But for now, it works. And maybe I'll figure out how to get that elusive inset hand for the primo sexy look. And yeah, that's it for the presentation. So thank you all. And if you have any questions about anything at all, then please do ask. And I'm going to have a quick little look through the comments so that I can answer all the questions that you guys asked. TV space, I think I did check the linear motors from Linmod. Those are the magnetic ones, if I'm not mistaken. I think I did, but they are very, very expensive. Yeah, I'll try to check them out. I'll try to remember to check them out again. The magnetic ones do look cool. I do like them. And brought to you by Dean. The end goal here. I'm not going to market it. I don't care about marketing things, to be honest. Don't care. But the end goal, there's many different goals. If you have a look at the banner on my YouTube channel, you can see some of those goals. I'd say the biggest one for me right now, the one that gives me the good vibes when I think about it properly, is having a big array of Jugglebots, like a 10x10 array, all juggling to each other in time with music, with glow-in-the-dark balls, like LED balls like these ones, so that they are, and they can like change color, like in time with the music. Would be like, wow. The camera does not pick that up well at all. And then also have a drone flying through, just for good measure, like the Tesla factory style footage. But that's a long way off. Another one that there's probably two other like medium goals on the way for that. One is to beat me, and to be able to do 7 balls like solidly. I don't think that's too far off. And then another one is to beat the human world record. That's a pretty big one. I think that will actually be quite tricky to do, because that guy is nuts. He's so good. Brought to you by Dean. What string am I currently using? That is a good question. And I have lots of strings. This is all that I can fit in my hands right now, but I don't want to move the camera, but you can take my word, there's a whole pile of strings right underneath the camera right now. To answer, yeah, the short answer is that I'm currently using this ultra high molecular weight polyethylene, and I think that I'll be sticking with this for quite some time because it is good. I was previously using this Kevlar stuff, and that was rubbish. This is like literally the worst string I could have picked. I actually might do this in next week's live stream, depending on how things go. For the last couple of weeks, I've been doing heaps of tests on lots and lots of different types of string, because I got lots of recommendations in the last couple of videos saying, you should do this string, you should do this string. So I just bought tons of them, and I've been testing them all out, and I've got one more test to go, and I'm just waiting for some stuff to happen to do that. And then I'm going to be publishing a Which String is King video, which I love that title, it's so good. Yeah, and we'll figure out why I've chosen this string. But yeah, it's so much better than the other ones. The Kevlar is like literally the worst. Like I've got like 13 different types of string. The worst one on like every single test that I've done so far is the one that I had before. I don't know what made me pick it. Metal components would be sick. Brought to you by Dean. Check out my Zulip page. If you go to pdj.zulipchat.com, maybe I can enter it in here. have it's sort of like Discord, but not. It's like Discord, but yeah, a little bit different. I don't really use Discord that much, so I don't really know the differences between them that well. But yeah, contact me on there, and I am very keen to get in contact with you. Metal parts will be very good. Tension the tubes, have a look at the tension. That's a good idea, William. That's a very good idea. I will write that down. Just give me one sec. All right. Post-tension slabs. Thank you. Yeah, I really like when there are already solved ways of, when there are already solutions to the problems that I'm encountering, but in like different things, different fields. It's very handy to know that people have actually dealt with this before and that it's not a brand new thing. How many of these full robots are you planning to juggle between? Yeah, 100, 1,000, as many as I can, to be honest. In this form factor, though, probably only 2. I don't think I'm going to get more than 2. To be honest, I'm kind of skeptical I'll get more than 1, because this is just big. There's so many parts. It takes me like literally a full day to just build the linear actuators alone. Building this platform took another like 4 hours, I think. And to be honest, most of that was just drilling the holes. So maybe if I had a better way to drill the holes, that would be a lot faster. But yeah, no, probably just 1 or 2 in this form factor. And then honestly, the cable robots, I've known for like the last 4 months that they are much better for this. And I just didn't know about them really when I started this. And now, if you've been following the project for a little while, you might remember that I had a bit of not an existential crisis, but like a potential inflection point in the design of the Jugglebot. And I was very strongly considering swapping over to a cable robot. But people have convinced me to stay, and Josh, actually, here you are. I remember you. You are one of the strongest voices that was in my mind convincing me to stick with the current structure, and I'm glad that I did, and I think that you were right. And the reason, for anyone curious as to why I wanted to stick and why Josh was suggesting to stick, is to learn, same as what I said before, learn what I can about the whole problem with the current setup. So for example, I already know that there's a problem with this design. It's too complicated, too many parts, it's not fast enough, it's not nimble enough, it's too heavy, there's a lot of problems with it, but it's still workable. Like, to juggle 2 balls in one hand, like, it's zero, like my hand needs to move, that's a very awkward pose, but my hand needs to move so little to do that. Like, you really don't need fast movement, you don't need, honestly, that precise movement. It's not that hard to do. So I'm very confident that this form factor will be able to do 2 balls in one hand, like 2 balls in one robot. I'm fairly confident it will be able to do 3, but I'm way less confident it will be able to do like 5 in one hand, because that's high and that's fast. But I can learn a lot about how to control a juggling robot with this form factor. And so I'm going to stick with this for a little while until it can do 3 balls in one hand, say, and then probably swap to a cable robot. And I think that will be much easier to build like 100 of them rather than building 100 of these. This would be way too much work. Yeah, no, SolidWorks Dark. I feel like I've been using SolidWorks Dark Theme for the whole time I've been, maybe not at the very, very beginning of the project, but I've been gray mode for a while. Yeah, it's no more white screens. No thanks. Don't want that. All right. I think that's everything. Yeah. Cool. Thank you for joining me again this week. I am not sure what we're going to be doing next week, so we will see what it is. I hope you all enjoy your weekend, and yeah, I'll see you next week.